Hello everybody and welcome back to Advanced Maths. Today we're looking at differentiating trigonometric functions. And before we begin, you need to know how to differentiate things. That includes knowing the chain rule, product rule and quotient rule. If you don't know this already, I'll link my playlist on differentiation below. Let's start with differentiating sine of x. If you differentiate sine of x, you get cos of x. This differentiates to minus sine of x, which differentiates to minus cos of x. And now, minus cos of x differentiates to sine of x. We've gone back to the start. And indeed, this creates one big circle where it goes round and round and round, and each one differentiates to the next one, and it goes round again. This creates one big circle where we've got sine of x differentiates cos of x, to minus sine of x, to minus cos of x, and then back to the start. Before we continue, it's probably a good idea to copy this down, so you can memorize this pattern. Let's look at our first example. So, example 1, find the gradient of these functions at x is equal to pi. F of x is sine of 2x, so we're going to differentiate sine. Sine differentiates to cos of x. So it will be cos of 2x, but there's a 2 inside the brackets. When you differentiate 2x, you get 2. So you're going to multiply the entire thing by 2. And you get 2 cos of 2x. And that's the chain rule. That's just how the chain rule works. Okay, so now we're going to substitute x equals pi into the expression. So f dash of pi is 2 cos of 2 pi. On your calculator, that gets you 2. So the gradient at x equals pi is 2. Now, let's look at g of x is 5 cos of minus x. Well, cos differentiates to minus sine, so this is going to be minus 5 sine of minus x. Inside the brackets, minus 1 of x differentiates to minus 1. Just remember there's a minus 1 in front of the x. And so that differentiates to minus 1. And so we multiply outside the brackets by minus 1. So minus 1 times minus 5 sine of minus x. Minus 1 times minus 5 is positive 5. So we get 5 sine of minus x. So there's a lot of minus signs there, and we have to be very careful when differentiating. Now, x is equal to pi, and we're going to substitute that in. G dash of pi. And we get 5 sine of minus pi on your calculator is 0. The answer, G dash of pi, is 0. Finally, h of x is minus sine of x over 2. We can differentiate this as minus sine of a half of x. X over 2 is the same as half of x, and it helps us differentiate if we think of it like that. Minus sine of x differentiates to minus cos of x, so this will be h dash of x is minus cos of a half x. But when we differentiate inside the brackets, we get half, so we multiply everything by a half. And that's the final answer. Well, the final differential, h dash of x is minus a half cos of half x. Substitute in x equals pi. And we type that into a calculator, we get h dash of pi is 0. So g of x and h of x both have turning points at x is equal to pi, which is interesting because the gradient is equal to 0. That's definitely a turning point. Finally, let's also look at example 2. We've got y equals tan of x, and we want to differentiate this. Well, to do this, we need to write tan of x in terms of sine and cos. And you need to remember that sine of x over cos of x is the same as tan of x. This is a famous trigonometric identity, and it's normally given in your formula booklet. So tan of x is equal to sine of x over cos of x. We have now written that function as a quotient, which means we can use the quotient rule. And the quotient rule says v du minus u dv over v squared is a derivative. Okay, so let's do this. U is sine of x, that's the thing on top, and v is cos of x, that's the thing on the bottom. We differentiate the u, we differentiate the v using our rules from before. Now we take the quotient rule and we substitute things in. Like this, and like that. Good. And then the bottom v squared is cos of x squared. This is the quotient rule. You should be familiar with the quotient rule. If you've not seen this before, you should definitely watch the quotient rule video to help you get there. That is in my differentiation playlist, which I've linked below. We can simplify this. This is cos of x times cos of x is cos squared of x, and minus sine of x times minus sine of x is positive sine squared of x. Now, cos squared of x plus sine squared of x is the Pythagorean identity, and it's equal to 1. Again, that's a really famous rule in trigonometry. Sine squared of x plus cos squared of x is equal to 1. So the top is 1 and the bottom is cos squared of x, and that's the final answer. dy over dx is 1 over cos squared of x. Done. Now, let's look at some tan rules again. So if we differentiate y equals tan of x, we get 1 over cos squared of x. If we differentiate tan of minus 5x, it becomes minus 5 cos squared of minus 5x. That's the chain rule again. And for minus 7 tan of 2x plus 1, if you differentiate that, you get minus 14 over cos squared 2x plus 1. So I just want you to spot the patterns there of how the chain rule works with tan. And that's everything for today's video. It's now time for you to do some practice questions. So please can you pause the video now and try these yourself. When you're ready, I'll reveal the answers in 3, 2, 1. How did you do? Please let me know below in the comments. Thanks for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. You can also check out advancedmaths.com for more useful revision resources. Thank you, and good luck in your exams.